Hello guys, welcome back to my channel. This is Trockers. Thank you so much for tuning in. If you are new here, please don't forget to follow me on Facebook and TikTok, Maybe Trockers, as well as subscribing to my YouTube channel, Maybe Trockers again. Okay, so today we want to talk about rates of change. Before we tackle this question, we need to understand what rates of change are. Okay, so a rate of change just entails us about how one quantity changes as another quantity changes as well. So for example, if we have this situation here, right, if we have a situation maybe where we are talking about the maybe the formula for finding the area of a triangle, where we are saying area is equal to half of our base times height, right? So we want to see, like, if we increase the height, what is going to happen to the base, to the area, right? Or maybe when we are talking about area, when we are talking about area here and the what area and the base, that's all about what about the rates of change. So now coming to our question, that is ZIMSEC November 2008 paper 1 question. The question reads: a solid consists of a hemisphere, right? So the key word here is hemisphere. So the question consists of a hemisphere of a radius r joined. So this hemisphere here, guys, is joined to a cone, right? So that's a hemisphere, that's the cone. They have a shared, a common radius there, a shared radius, right? So the base of the cone is the plane surface of the hemisphere, right? We know that, our cone looks like this. It has this circular base. Then we have a hemisphere. It has the circular base. But we are told that this base of the cone, right, is this plane face of a hemisphere, right? So make sure you take note of this part, right? Then if r increases at a rate of 2 centimeters per minute, r is the radius, right? So we are told that the radius here is increasing at a constant rate of 2, right? So it's just 2 centimeters per minute, right? Calculate the rate of increase of the volume of the solid when r is 60. So we want to find and we are going to leave this answer in exact form, like in terms of pi. So we want to find the rate of what increase of the volume. So this is the combined volume, meaning say we want to add the volume of a cone, right, and the volume of a hemisphere. So volume of a cone, remember, is just 1/3 base area times height. So which is 1/3, my base area is pi r squared, plus volume of a hemisphere is half of the sphere. So what is given here is the volume of the sphere, which is the 4/3 pi r cubed. And when you divide that by 2, you must get 2/3 pi r cubed. So this is what we need to, that's what we need to have here, right? So now let's proceed with the question. Okay, so I need the whiteboard here. Okay, a solid consists of a hemisphere. So I'll try and put the diagram here for reference, right? Okay, I'll put the diagram for reference here. That's my radius, that's my height, right? And we are told that in this case, a solid consists of a hemisphere of radius r joined to a cone of constant height 60, right? So the cone, it has height of 60, right, centimeters. Then if r increases at that rate, so we are also given gr dt is 2 centimeters per minute. This is all the given information. Now we want to calculate the rate of increase of the volume of the solid when r is 60, right? So what we're going to do is the total volume of the solid is volume of the cone, volume of cone plus volume of hemisphere, right? So this is the volume of the cone plus volume of the hemisphere, okay? So we know that our volume of sphere is 1/3 base area, which is pi r squared h, plus our volume of hemisphere, which is 4 over 3 pi r cubed divided by 2, which is 2 over 3 pi r cubed, right? So now, what is needed here? So we are given r and this. So this is my volume. So first, we need to calculate volume with respect to the radius, right? So before we do that, we are told that the height is 60, right? So the height of the cone. So V is equal to 60 over 3, that's 20. So that's 20 pi r squared plus 2 over 3 pi r cubed. So I have to differentiate volume with respect to radius, right? So here it's I'm getting 40 pi r, right? That's my 40 pi r plus here it becomes 2 pi r squared, right? But we are told that when r is 60, right? So when r is 60, we are going to plug in 60 for this. So this is 40 times 60 of pi plus 2 times 60 squared pi. I forgot my calculator, but I'll try, right? That's 0 here, 0, 0. So this is 2,400 pi plus, I believe 60 squared, it's 3,600, right? Then times 2 is 7,200. So this is 7,200 pi. And when I add those two together, right, 0.069, so this simplifies to 9,600 pi. We are not yet done. This is dVdr, right? But remember, we want to find, we are given dr dt and this, and we want to find dVdr. So to find, we want to find dV/dt. So to find dV/dt, it is going to be the given, if I say dV/dr, so it's dV/dr times dr dt, right? So which is dV/dr is this one, 9,600 pi, right? And remember, volume is cubic divided by this. So these are square centimeters, right? Times dr dt is this one, which is 2 centimeters per minute, and these are square centimeters. So if I multiply this by 2, 0, 0, 12, 19,000. So I'm getting 19,200 pi cubic centimeters per minute. So that's how we find the rate of change of this whole solid with respect to time, right? I mean, that's how we find the rate of increase. Obviously, the rate of increase, we are finding the rate of change of volume with respect to time. Thank you so much, guys, for your time. Continue to watch more videos. Have a good one.